Hello, this is Mr. Wynn, and this video is over geometric proofs. So since geometry also uses variables, numbers, and operations, many of the properties of equality used in algebra are also true and also used in geometry. You will use them in addition to all the other geometry rules, properties, postulates, theorems, and definitions. Here's a list of all the ones you should know so far. This side, there you go. So first we have the definition of congruent segments. If one segment is congruent to another segment, that squiggly mark, that means their measures are equal. Definition of congruent angles. If two angles are congruent, then their measures are equal. Definition of bisect. If you bisect something, it cuts its two congruent parts. Definition of midpoint, or the midpoint theorem. If M is the midpoint A to B, then the first piece is congruent to the second piece. AM is congruent to MB. Segment addition postulate. If B is between A and C, you net A to B plus B to C equals A to C. Right angles theorem. All right angles are congruent. Definition of right angle, they're exactly 90 degrees. Definition of complementary is two angles to add up to 90. Definition of supplementary is two angles add up to 180. Supplement theorem is if angles from a linear pair, then they are supplementary. They make 180. Vertical angles theorem, two vertical angles are congruent. They're equal to each other. Angle addition, you add two little angles to pick the big angle. Definition of perpendicular means that they intersect at four right angles to make 90 degrees. Congruent complements, if two angles are complementary to the same angle, or to congruent angles, then those two are congruent. Same for supplements, if two angles are supplementary to the same angle, or to congruent angles, those two are also congruent. Alright, so here's an example. Angle ABC is a right angle. Prove that angle 1 and angle 2 are complementary. So we have our two-column proof. Remember, we start out with given. So they told us angle ABC is right angle. So what can I do with that? If it's right angle, I say, oh, right angles are 90 degrees. So why am I allowed to write that? That is the definition of a right angle. Now what can I do from here? I can maybe create an equation. So I'll say, oh, measure angle 1 plus angle 2 equals measure ABC. That is the angle addition postulate. So the top angle plus bottom angle makes the whole angle. From here, what can I do? I could replace measure angle ABC with 90. That is substitution. Now when I see angle 1 plus angle 2 equals 90, that means they are complementary. Because two angles that add up to 90, that's the definition of complementary. So we're done. Here's another one. If angle FGJ is congruent to angle JKJGK, so this left angle is equal to this top angle, and angle JGK right here is congruent to KGH, is right angle, so top and right are also equal, prove x equals 6, or the two-column proof. Alright, so obviously start with given, start with all of that out. Then, what can we say? We can say, oh, FGJ is congruent to KGH. So how do I do that? I use this first line here, these first two. I said, hey, if this angle equals JGK and this angle also equals JGK, you could say transitive property, or you can say substitution. Alright, I just replace this JGK with this JGK, which is equal to KGH. Done. Now what can I do? I can say if angles are congruent, then the measures are congruent. Okay, that's this definition of congruent angles. So basically I'm trying to get rid of that squiggly mark, the congruent sign. Now if I say the measures equal, I can actually do substitution. Plug in the formula. So this is 6x plus 7 equals, the other side's 8x minus 5. So I just did substitution. Then when it's off for x, so I'm going to move x to one side. I'm actually going to go to the left. So I'm going to subtract 8x. So I get negative 2x plus 7 equals negative 5. So our subtraction property of equality, I subtract 8x. Now you could move the 6x to the right, but then you have to do symmetric property at the very end. So I'm trying to just move x to the left. I'm going to subtract the 7x. So that is the subtraction property of equality. Then I'm going to divide by negative 2 to get x equals 6. That's what they want. So we're done. That's good. Alright. That's it for the video. Hope you enjoyed it. Make sure you ask any questions. Thanks for watching. Bye.